Assalamualaikum. Today we're going to look at our waste assignment video assigned by Dr. Razamri. But before that, let me introduce myself first. So my name is NURUL BINTI AZHAR and my metric number is 207016 and my members including NAJAH FARAHIN and NURUL FATIN AMEERA. Waste is a product or substance which is no longer suited for its intended use, whereas in natural ecosystems, waste like carbon dioxide, less organic matter and oxygen is used as a food or a reactant. Waste materials is basically resulting from human activities that are often highly resilient and take a long time to decompose. Figures show the different activities that generate different types of waste. As you guys can see, humans are presently consuming more natural resources each year than the earth can replace. As a result, our continuous excessive use of resources and production of massive amounts of trash is fueled by our sense of authority over nature. According to Fusions, food waste is any food or inedible parts of food removed from the food supply chain to be recovered or decomposed, that including compost, disposal to sewer, landfill or discarded to sea. Inedible parts of food such as skin and bone are also part of food waste too. In this video, we're going to concentrate on finding the best way to handle the waste from the preparation, processing, and rendering of visceral organs of meat, fish, and other animal-derived commodities. The visceral organs are the internal organs of the body, including the lungs, heart, reproductive system, and others. Food waste is increasing at an exponential rate, creating several dangers to our society, such as pollution, health risk, and a lack of dumping land. An aerobic digestion approach has appeared as one of the most eco-friendly and promising solutions for food waste management, energy, and nutrition production, which can contribute to the world's ever-increasing energy requirements. Besides, an aerobic digestion system has lots of benefits, such as biogas that can be used as a renewable energy sources, not only improve the energy balance of a country, but also contribute to the preservation of the natural resources by reducing deforestation and to environmental protection by reducing pollution from waste and use of fossil fuels. Next, we are going to look at the three main components in process chain of anaerobic digestion of bio-waste, which are substrate chain, transformation, and product chain. First, we have substrate chain, which consists of waste generation, collection, transportation, and supply to the digestion facility and necessary pre-treatment of waste before feeding to the digester. Then, transformation process, which we have biological and chemical transformation process of feedstock in digester, which leads to value of products. The first step is hydrolysis, the slowest of the four degradation steps. Bacteria transform complex organic materials into liquefied monomers and polymers. The second step is acidogenesis. This is the step where sugars and amino acids are converted. The third step is acetogenesis, where the substances are then transformed into hydrogen, carbon dioxide, and acetic acid. The last step is methanogenesis. In this step, the methanogen bacteria convert hydrogen and acetic acid into methane gas and carbon dioxide. Typically, the gas mixture will also contain hydrogen sulfide. It smells like rotten eggs, but also oxygen, nitrogen, and hydrogen. In volume percent, methane amounts to roughly above 60%, while carbon dioxide is around 40%, and hydrogen sulfide is usually lower than 2%. The next one is product chain, a post-treatment of outflows from the digester that refine this into improved value products and their distribution and utilization. Next, I will pass it to the next member's FATIN. Thank you.
Operational parameters of anaerobic digestion, AD. The rate at which the microorganism grow is of paramount importance for the anaerobic digestion process. Therefore, the digester's operational parameters are managed to improve microbial activity and raise the AD efficiency. An important parameter in anaerobic digestion is the organic loading rate, OLR. OLR is a measure of the biological conversion capacity of the AD system. This parameter quantifies the substrate quantity per reactor volume and time. OLR is a crucial control parameter in continuous system, but if it's too low, it will cause large reactor. If it's too high, it will cause overload or acidification reactor. A good daily loading rate for unstepped reactors is 2 kg vs meter cube reactor per day or below. With a step reactor, this can be higher. You can increase this up to a loading rate of 4 to 8 kg vs meter cube reactor per day. Next, the parameter is pH. The optimum pH for a generally stable AD process in the range of 6.5 to 7.5. This pH is actually quite neutral. During digestion, the process of hydrolysis and acidogenesis occur at acidic pH level, which is pH 5.5 to 6.5, as compared to the methanogenic phase, which is pH 6.5 to 8.2. The pH is slightly lower in the acidic phases than it is in the methanogenic phase. Now, acidogenic bacteria will make the reactor acidic if the loading rate is too high. Since methanogenic bacteria are more sensitive to this condition, they will be inhibited. In response, the loading rate should be decreased. Additionally, lime or sodium hydroxide might be used to raise the pH level. Another factor influencing the AD process is temperature. Temperature below 15 degrees Celsius are not ideal and anaerobic digestion not work. As a result, the organism activity significantly slow down. The anaerobic process is most comfortable in two temperature zones, which is the mesophilic temperature zone between 30 and 40 and the thermophilic temperature zone between 45 and 60. However, underground construction or installation can buffer this temperature range. Mesophilic operation is more stable, can tolerate more change in condition, and use less energy. Mesophilic organisms, on the other hand, degrade more slowly, so you must give them more time. The system is more sensitive to alteration, although thermophilic organisms are faster. Further parameters that influence the process of AD is hydraulic retention time. The hydraulic retention time quantifies the time the liquid fraction remains in the reactor. The hydraulic retention time required to allow complete AD reaction varies with different technologies, process temperature, and waste composition. Recommend HRT for waste treated in a mesophilic digester range from 10 to 40 days. Retention time will be low if the reactor volume is small for the input use, which will result in a low yield of biogas because the process will take less time. Retention time increase and yield improve with larger reactor volumes, but at the expense of larger reactors requiring more space and cost. Another parameter is the carbon to nitrogen ratio. The relationship between the amount of carbon and nitrogen in organic materials is represented by the CN ratio. Optional carbon-nitrogen ratio in anaerobic digester are between 16 and 25. A high carbon-nitrogen ratio is an indication of rapid consumption of nitrogen by methanogens, which then result in lower gas production. On the other hand, a low carbon-nitrogen ratio causes ammonia accumulation and pH values may exceed 8.5. Although methanogenic bacteria can adapt to very high ammonia concentration, this only happens if concentrations are increased gradually, allowing time for addition.
So I will continue the classification of anaerobic digestion technology. Numerous anaerobic digestion technologies for the treatment of biowaste have been developed worldwide. Biogas system can be classified according to critical operating parameters and elements of reactor design. There are plenty of digester both in the industry, and for that we need to choose the suited digester according to the parameter of the digester and also the relation with the feedstock. The example of the digester are floating drum digester, tubular digester, fixed dome digester, and garage type digester. So in this part, we are going to look at the specified operating parameters of the feedstocks and which digester will treat visceral organ waste. So the first parameter that we need to see is the total solid content, which does the feedstock need to be on a wet system or dry system. So for wet systems, the feedstock need to have a total solid content 16 or less, while for dry, the range of total solid should be 22 to 40%. As for the differences, dry systems are considered better than wet aerobic digestion. Dry digestion requires a smaller reactor volume, which indicates that it needs lower energy requirement if heating is required, and minimal material handling effect. Due to the low moisture content of the digestate after dry, an aerobic digester, it can easily be used as fertilizer or be pelletized and serve as biomass fuel. The second parameter is feeding mode. There are two types of feeding mode systems, which are batch and continuous. In batch fed digester, the reactor are filled with a feedstock, closed and left for a period of time, then opened again and emptied. Batch system represent the lowest technology of all systems and are also the cheapest. In a continuous feeding mode, new feedstock is added at regular interval, while an equivalent volume of slurry leaves the digester, thereby providing a continuous process of digestion. The third parameter is operating temperature, which are mesophilic, which are 30 to 40 degrees Celsius, and thermophilic, which are 45 to 60 degrees Celsius. Mesophilic systems are considered more stable and require less energy input than thermophilic digestion system. Meanwhile, the higher temperature of the thermophilic digestion system facilitates faster reaction rates and faster gas production. Operation at higher temperature also facilitates hygiene of the digestate. The last parameter is number of stages. The rationale of two and multi-stage system is to sequence the biochemical reaction that do not necessarily share the same optimal environmental condition. Single-stage systems are simple, easy to design, work and operate easily, and are generally less expensive than multi-stage systems. So based on all parameters stated before, which digester will be suited for visceral organ waste. According to this table, we can find visceral organ on market waste, leftover waste, and bio waste, which the average of its total solid will be 20 to 40%. So according to the total solid, we should choose dry system as the industry required and more preferred for cheaper technologies. Batch systems treated more, and a batch system provided mesophilic system due to the tropical climate. According to Nicholas 2004, single state is used mainly for small decentralized waste management units, while multi-state digestion is suitable for a plant with a capacity of more than 15,000 tons per year. So based on the statement, we will choose single state system as one of the parameters to treat visceral organ. So based on all the parameters, garage type digester is the best digester for feedstock of visceral organ. So we have come to the end of the video, and as the conclusion, with the rapid increase of the food production industry, high risk aspect associated with slaughterhouse and wet market should not be neglected. Visceral organ produced from slaughterhouse and wet market are of a broad spectrum, and these are the growing ground for infectious disease. Different variants in slaughterhouse bio-waste composition require proper sorting and segregation for efficient waste management and selection of efficient treatment method. And that's all from us. Thank you for lending your ears.